All right, folks, welcome to History of the Atom Notes Part Number 2. Love that history. It's going to be a positively charged time. Atoms. I've used that joke like 3 times already. It's better every time. So remember, we left off with John Dalton, Dalton's atomic theory, and his significant contribution where he is the first guy to come up with a model of the atom. Even though his model wasn't very accurate, remember it was just a ball, the marble model, it was significant because it sort of got people on the track of creating models for atoms. Now, we will see how the model begins to become more complex as we gain more information over time. So that brings us to J Thompson. Come on down. All right. So here's J Thompson. What are the things you need to know about him? This man discovered the electron. This is a big deal. J Thompson discovered the electron. And he did that using a cathode ray tube. So J Thompson made a huge step forward in the understanding of what an atom is. Now, I'm going to sort of show you visually here, and I'm also going to give you a video in a second of the cathode ray tube. So basically, he was firing this beam of particles, okay, through this tube. And at first, they would just go straight on through just like this. Now, he didn't know what this beam was, but he started to mess around and test it a little bit. When he took a magnet and kind of held it this way, okay, when he took a magnet and kind of held it this way with the negative end, what would happen is this beam would bend away from that negative end, okay, kind of bend away from the negative end like that. When he flipped this guy around, okay, so when he held the positive end this way, that beam would then kind of become attracted to that, and it would sort of bend upwards like this and go like that. So he learned a couple of things. Okay, so if the beam avoids the negative end of a magnet, the beam itself must be negative. Remember, because opposites attract. So he knew that the beam was negative. And again, when he flipped it over, and the positive end of the magnet, like it is right here, was facing the beam, then the beam would bend towards it. It's like, okay, so that beam must be negatively charged. And based on how far that beam would bend, he could calculate that the little particles in that beam must be really tiny. So he learned that they're really tiny and that they're negatively charged, and hence the idea of an electron is born. Now, to sort of just give you another visual of a cathode ray tube here, here's what it kind of looks like. So this green, like laser-looking thing, that's the beam of electrons. And he's going to hold a magnet at the top. So see how it bends towards that magnet? That's when he's holding the positive end towards them. If he flips that magnet over, he can make the beam bend away, indicating that the negative beam, or the beam must be negative because it avoids the negative part of the magnet, but it is attracted towards the positive part of the magnet. Now, what did he do with this information in terms of his model? This led to the Plum pudding model, the Plum pudding model, and where plums are electrons, okay? So you're like, I don't know what plum pudding is. Plum pudding is a super gross dessert, okay, that he loved to eat. So this is just like a big chunk of stuff, and there's like little pieces of plum in it. And so what he was like, he's like, okay, so the plums are electrons. The pudding is like positively charged material. And so if you want to kind of picture something like this. So I'm going to erase this guy here. So he basically envisioned, like, okay, so you have this big blob that's kind of positive. And then you have these negative sprinkles on the surface of that blob, just like a plum pudding has plums sprinkled on the surface. And that's what an atom is really like. So it's not just a ball, it's like a positively charged ball with negative sprinkles. I think of this as a raisin cookie. So I hate raisin cookies. They are imposters, and they make you think it's a chocolate chip cookie until you bite into it, and then you're really upset because it's not a good chocolate chip cookie. It's a terrible raisin cookie. And so picture the cookie. The cookie's nice and positive, but you have these terrible negative little raisin sprinkles on it. I don't know. I've never had plum pudding before. I bet it looks about the same going in as it does going out. I don't know. But anyways, so that was his model of the atom. So no longer is it a ball, but it's a positively charged mass with little negative sprinkles, aka electrons, on it. And he found that out because of his cathode ray tube. Now this brings us to the man with an amazing mustache. Look at this thing. Boom. Oh yeah, that is a healthy mustache right there. Ernest Rutherford, okay? Ernest Rutherford, and he is famous for his gold foil experiment, the gold foil experiment. So he was working with J Thompson's idea, our model of an atom, where it's like, okay, it's a positive blob with little negative sprinkles, okay? So that's what he thought going into this experiment. So here's what he was doing, okay? He had some gold foil and alpha particle emitter. So basically there's this block and it shoots little positive particles out through it. And so you're shooting positive particles out, so they're going through here. And most of them kind of just go right through the gold foil, which is what he expected. Okay, so here's your plum pudding model. He's like, okay, so if I fire particles, they're just going to go right on through, okay? Going to go directly through this soft little mushy plum pudding idea. But what actually happened was most of them would go through, but every now and then some would glance off and kind of go in a random direction, or some would even bounce backwards, like this guy right here. And you're like, okay, well, how is that possible? Well, here's what he concluded. That there is a nucleus, okay? So he concluded that there is a nucleus. There is a nucleus. And why was that? Well, here's kind of the picture he's getting. He's like, okay, well, most of these are going right on through. So these alpha particles I'm firing, most of them are going right on through, just like this guy right here, or maybe this guy right here. But for some of them to bounce back, okay, these positively charged alpha particles, they must have hit something kind of dense. They must have hit something kind of dense. So he realized, okay, there must be a nucleus or like a center to an atom. It must be small. Why small? Like, well, because most of the time the particles went right through. So most of the time they're missing that nucleus, so it can't be that big. But it must also be positively charged. He could tell that the way that these positively charged particles were flying away or bouncing off that nucleus means the nucleus itself must also be positive. And he also concluded that it must be like massive or really dense. So he came up with the idea that there must be a nucleus, that it must be really small, that it must be positively charged, and that it must be really dense. It must be really dense. How else could those particles bounce backwards unless they hit something that was pretty dense? And so that leads us to a new model of the atom, where atoms are mostly empty space. So you have like a little positively charged nucleus right here. You have all kinds of empty space around where maybe the electrons are sort of flying around out here or something. But atoms are mostly empty space. And this is a huge idea. This is way different than that ball model, that marble model we started off with early on with Dalton. This idea that atoms have like a tiny, really dense, but positive center called the nucleus. And surrounding that, there's like pretty much empty space. And there's electrons somewhere on the outside, I guess. And that's pretty much what Rutherford concluded. So the model of the atom has become a lot more complex and sort of changed as we've gained information. So that is our Ernest Rutherford. And so we've gone from Dalton's model of a ball to Thomson's plum pudding model where it's like, yeah, it's a positive ball with negative sprinkles, to finally Rutherford's like, here's the positive ball in the center, and the little negative electrons are sort of around that, not really sure where, but most of this is empty space. And that is where we're going to leave off with the history of the atom, notes number 2. Oh, yeah. You guys are all done with me for the rest of Thanksgiving break. Go eat some turkey. Go into a mashed potatoes coma. You do you. But make sure you check your email every day or so, like maybe just once a day, in case there's any messages from me or from the district. All right? You guys have a good one. I'll see ya.